Hi guys, so this is day 2 of week 2, and we are just going to continue solving rational equations today. Specifically, we're going to look at them with some applications and some real world problems. We're also going to look at what are called literal equations, which basically instead of having as many numbers, we're going to have a lot more variables and find our answer in terms of other variables. All right, so if you guys saw, there was a separate little YouTube clip posted from a movie called Little Big League. This is a movie from my childhood that I really enjoyed, and I know it's a little old and not quite HD, but it does show an example of a question that can be solved using rational functions. Now, the answer that they came up with is correct, but the math behind it's really kind of hard to see. So I'm going to show you guys kind of how that answer comes about and how we're going to use it to set up these rational equations for some different ones that are a little bit more difficult. So Joe can paint a house in 3 hours, and Sam can paint a house in 5 hours. We want to know how long it will take them to paint the house together. Well, the problem is we can't just add 3 and 5 because 3 and 5 is the time it takes them per house. So what we need to consider is their rate, the rate of working. So if you think about it, distance is equal to rate times time. We all know that. Well, if we have rate times time in a different sense, that could also equal the amount of work that we're getting done. And I know that's a different work than the work you have in physics. But what we're saying is basically just the amount of something to get done in a particular amount of time. Well, if I want to know what that rate is on its own, I can divide by time. So we can say that the rate is the amount of work you get done divided by the time it takes you to do that, and that would be your rate. So Joe's rate to paint the house, he can get one house done in 3 hours. Sam has his own rate. Sam can get one house done in 5 hours. And we want to know how long it'll take to paint them together. Well, what we need to do is we need to find their combined rate. So we need to add their rates together. And what that's going to give us, it's not going to give us the time, it's going to give them their combined rate. So what I need to do is really just solve this rational equation. 1 over 3 plus 1 over 5 equals 1 over x. So need a common denominator. I'll multiply by 5, multiply by 3, and I get that 8 over 15 is equal to 1 over x. So 8x is equal to 15, and x is equal to 15 over 8. But again, we don't really talk about time as 15/8 of an hour. That doesn't really make sense for us. So we're going to convert this. 8 goes into 15 one time, with 7 left over, so we 1 7/8 of an hour. If you want to get detailed and convert that to minutes, you're welcome to. But again, we'd probably want to calculate at this point since it's not very pretty. You can do 7 over 8 times 60 to get the minutes that are involved here. But that's how long it would take them to do it together. Now we're going to use this same kind of method for some other questions that are going to be more actual rational functions and not just simple fractions. So let's look at another example. All right, it takes Harry 7 more hours to paint a kitchen than it takes Sally to complete the same job. Together, they can complete the same job in 12 hours. So again, what we need to do is consider their rates. Okay, their rate is the amount of work they get done divided by the time they do it. So Harry can get one kitchen done in 7 hours more than Sally. So he would be x plus 7. Sally is going to be just 1 over x, okay? Because whatever her time is, we know Harry's time is going to be 7 hours more. So that's Sally's rate. Combined, they're going to get that job done in 12 hours. And again, it's not going to equal 12. It's going to equal their combined rate. So that is one kitchen in 12 hours. So how long would it take Harry to complete the job if he works alone? So at this point, we're just solving that rational equation. So 1 over x plus 7 plus 1 over x equals 1 over 12. Left fraction gets multiplied by x. Middle fraction gets multiplied by x plus 7. And then if you want to cross multiply, I think that's how I'm going to work this one out. I'm going to leave it as 1 over 12. So this becomes 2x plus 7 over my common denominator. I'm going to cross multiply. Since it's quadratic, let me rewrite it up here for you. I'm going to set it equal to 0. And I'm going to write the correct number. That's not 14. That should be 17. So now that it's quadratic, I can factor. So what multiplies to negative 84 and adds to a negative 17 would be negative 21 and 4. So I get x equals 21 and x equals negative 4. Well, let's think about this problem. Okay, negative 4 doesn't really make sense. It's not going to take you a negative amount of time to get something done. So that means that x is 21. We also need to consider what that means in our problem. It takes Harry 7 hours more to paint a kitchen than Sally. So Sally's rate was 1 over x. So 21 hours is how long it would take Sally. Harry is going to take 7 hours more, which would be 28 hours. All right, so again, when it comes to these word problems, the big thing we need to make sure we do, set these up as their rates. Okay, their rates is the amount of work they get done divided by the time it takes them. We can't just set up the times and say and combine them together and add them up. We consider the rate that they're working and their combined rates together. All right, so one more problem that involves this same type of concept is when we're looking at, again, distance, rate, and time. This one's a little bit different just because of the information that we know. So in this case, a car travels 500 miles in the same time that a train travels 300 miles. The speed of the car is 30 miles per hour faster than the speed of the train. So again, we know distance is equal to rate times time. Well, let's look at the information that we know. We know that the times are going to be the same. We don't know what that time is, but we know they're going to be equal. So if I want the car to be equal to the train, the times are what are going to be the same. So in this equation, I would divide both sides by r. Time is equal to distance divided by rate. Since the times are equal, the car's distance over rate is going to equal the train's distance divided by its rate. So let's go ahead and find the car's distance divided by the car's rate. The car's distance is 500 miles. The car's rate we don't know. What we do know is that the rate of the car is 30 miles per hour faster than the train. All right, then let's look at the train. The train's distance that's equivalent to the car is 300 miles, and the speed that it's going, the rate that it's going, is x. We don't know what it is. At this point, you have your rational equation. Let's go ahead and solve. So that would give me 9,000 plus 300x is equal to 500x. So 9,000 is equal to 200x. And x then in that case would equal 45. But again, think about what that means for the problem. X is the speed of the train. So the train is 45 miles per hour. The car is 30 miles per hour faster, which is 75 miles per hour. Okay, so a little bit of a different setup just because of the information that you knew versus the information you were trying to find, but very similar in the fact that we're taking that distance equals rate times time equation, and we're trying to convert it basically into a fraction and solving that rational equation. All right, so the last thing that we're going to look at today is what we said are called literal equations. And what that means is we're finding our answer in terms of other variables. Now, you guys have done this before, even in Algebra 1, okay? Back when you had 3x minus 7y equals 4, and you had to solve for y to graph it, okay? That's kind of like these problems that we're doing right now. You're finding y in terms of x. Well, we're going to find whatever variable it asks for in terms of the other variables. So on this first example, it's telling us to solve for x. So I need to get x by itself, and my answer is just going to have a bunch of variables in it. So in order to solve for x, what I need to do is I need to combine these two fractions together. Now, there is more than one way to work these out, so there's different methods you can use if they make more sense to you. As long as your answer at the end has x by itself, then you're good. But I'm going to go ahead and get a common denominator. So that means I would multiply by y, multiply by x, and now that left fraction is the same. All right, then we'll go ahead and cross multiply. Then I can go ahead at this point, I'm solving for x. So in order to get x by itself, just like we did with inverses, I'm going to put everything with an x on the left side, every term that does not have an x on the right side. Then at this point, I can factor out the x. And then to solve for x, I can just divide by what's with it. So kind of similar to what we did with inverses. So even though your answer has a bunch of variables in it, that is your answer. Okay, it's going to be x basically in terms of all those other letters. Those of you guys who are already in physics, you've probably done a lot of questions that are similar to these. It's a very similar process. All right, let's look at B. All right, so B wants us to solve for P. Again, more than one way to get there. What I'm going to do first is subtract 3. Well, then I can go ahead and multiply both sides by 2, or cross multiply, however you want to look at it. And then since I'm solving for P, one last step, just subtract x. And I'm done. Again, more than one way to get to your answer. If you wanted to combine these together with a like denominator and then go from there, that would still work. You'd still get there. It's just a matter of which method you think makes the most sense for you. All right, let's try another one. So in this case, we have a fraction equal to a fraction, so cross multiplying is probably going to be our best method. So cross multiply. And now it says I'm solving for x. So let's go ahead and multiply everything out and get x by itself. Okay, so that's if I FOIL out the left. Again, I went a little fast on that, but that was x times a, u times a, x times negative u, and u times negative u. Okay, just FOILing it all out. Let me distribute on the right side. All right, so now that we have all these terms listed, what we're going to do, we're going to go ahead and solve for x. Well, let's try and get all the x terms on the same side. Well, if I add ux to the other side, that's going to cancel out. Same thing with if I subtract au. Well, au and au are the same, ua and au are the same term. So that's going to cancel out, and that's going to cancel out. So I'm left with ax minus u squared equals 0. So now all we gotta do is get x by itself. We'll add u squared to the other side. And I'm done. All right, the last one can be a little bit messy, and this is going to be kind of similar. If any of you guys watched that complex fractions video, this will be a little bit similar to kind of that method. Now, this is probably harder than anything you guys will see on a check, but it's really good practice for you guys because it combines really everything we've been doing together for the last 2 weeks into one problem. Okay, so what I'm going to do here, I'm going to start by simplifying the numerator of this question. So in order to simplify the numerator, I would get a common denominator. That means I'd multiply the left by t, and I'd multiply the right by s. So that would give me t plus s over s times t. Now I'm going to do the same thing, and I'm going to simplify the bottom. Well, this fraction needs t, this fraction needs s, so that leaves me with t minus s over s times t. Now remember, those two fractions were being divided. So what I'm going to do is I'm going to rewrite this horizontally. T plus S over S times T divided by T minus S over S times T. When we divide fractions, we flip the second and multiply. And if I do that, you guys will notice ST cancels out. So everything that we had here on this whole right side simplifies to just T plus S over T minus S. So V is equal to T plus S over T minus S. So now we're going to solve this equation, which will be a little bit simpler. So I'm going to go ahead and rewrite this over here on the left, just so we have a little more workspace and that watermark doesn't block any of this out. All right, let's cross multiply. And again, I'm trying to solve for S, so I want every term with an S on one side, every term that doesn't have an S on the other. So this is going to become S plus Vs. This is going to become Vt minus T. Factor out that S. Divide by what's with the S, and I end up with my final answer. Now, if you want to factor out that T on the top and make that T times V minus 1, you are welcome to. You don't need to, though, because you're still getting the same answer either way. All right, so that is it for solving rational equations. Again, if you guys have questions, feel free to email me, fill out that video request. But your to-do, again, is going to look pretty similar. Make sure you've watched the video, taken your notes, work your practice problems. Again, on these, you do need to show your work. And for those word problems, that's really showing the equation and the work to solve it. You are allowed to use a calculator on those word problems. But again, you got to know how to set them up first. If you need to see the video, fill out that video request, and I will get those done for you guys. And then don't forget about that week 2 assessment. That's also going to include what we did on Tuesday.